Ladies and gentlemen, welcome again to the quantity surveying platform or the QS platform. Fortunately, today we are about to be learning the estimation or having an introduction about the estimation of course. Last course was about the simple architectural design using Archicad 21, and today I'd like to switch to the estimation part. Let's have a short introduction about the estimation of course. If we say estimation, we clearly understand the bills of quantity. It's an estimation document or a main estimation document, of course. Here, I'd like us to have a short introduction about the bills of quantity. In the bills of quantity, the format is like this, as you can see. Here, we'll be having an item column. We'll be having, just for numbering, we will be having a description column where we'll be describing the work to be undertaken either by the contractor or the subcontractor or whoever else who's using these bills of quantity. For example, as you can see, the bills of quantity is actually divided under the sections. As you can see, this is the section number 2, which is builder's work. We've already, not yet, but this section called preliminaries is the main first section for every project or every work. Or the preliminaries are the works to be carried out before the construction phase begins actually, physically, or here you may see the site accommodation, the temporary services like electricity. Here we may be having the safety and environmental protection. Here we may be having the contractual expenses and so on and so on. So this is the section number 1, of course, and section 2 is about the builder's work. In the builder's work, of course, the main section of the building, which is of course a construction phase from the substructure up to the finishing works or external works. So I won't be talking much about the bills of quantity, as I'm not here to introduce about the bills of quantity yet. Let's just have a clear understanding about how it should be formatted. Here I was saying about the description column where we describe the work to be carried out. For example, here they are saying under the substructure we have a site clearance, which should be specified as follows: clearing the site of vegetations, undergrowth matters, and all bushes, trees, shrubs, and so on and so forth. Here maybe having excavations. They also describe how should it be done. After the description column, we will be having a unity column, which will be indicating the measurement under which we are using to be measuring a certain work described. Here we'll then be having the quantity column, which will be, of course, the quantities that we've already calculated. And here we'll be having a unity rate. It shouldn't actually be rate. It should be, unity rate, okay. Then after the unity rate, of course, we'll be having the amount, which will be equal to the multiplication of these two columns, the quantity and the unity rate. At the end, we'll be having the bills of quantity total regarding the elemental sections that we've already used. We may be having the preliminaries here. We'll be having a subtotal of preliminary, the substructure, the reinforced concrete framework, and walling, the openings, the wall finishes, the floor finishes, ceiling finishes, roofing, plumbing and drainage, electricity, and finally at the external works. It's not mandatory that the bills of quantity will always be having these subsections or elemental sections. You may be working on a huge project which will be having more than these. These are just a sample for understanding how a bills of quantity should be looking like. After this, on the BO key total, we'll be having the total value of the building, but here we'll be excluding the VAT or taxes. It will actually be the sum of these, of course, and then we'll have to add a certain percentage of contingencies depending on the project type or the project quality or even the project size. Here then we'll be having to total the value of the building without VAT again, because will be the sum of this and this one. Of course, we'll be having the total of this plus contingencies, and then we'll be having to add the VAT, which is 18% of the total amount or the total subtotal, and then the grand total with a VAT will then be granted. And here was a clear and short understanding about how the bills of quantity should be prepared. And then I come back to these bills of quantity. Of course, as I said, I'm not here yet to introduce about the bills of quantity. The form or the other document I'll be introducing about today is one holding these quantities. How do we actually measure these quantities? And then I'll be closing this. Okay. So I'll be introducing another document called a takeoff list. So a takeoff list, what is it actually? It sounds as it means, because a takeoff list, of course, it is a list or a document containing, or we use to be, how can I say this? Okay, it is a document used to be taking off dimensions from a drawing to insert them in here so that you may produce the quantities under which we'll be using in the bills of quantity. So this is the general format of a takeoff list. It is not a document to be presented. It is I'll be saying it as a drafted document for the estimator performing any kind of work. So here it is, its general format. Here we have a numbering column or maybe an item column, of course. And then here I'll be having this column which is called a multiplication column. Here I'll be having what we call a dimension column, and here we have a squaring column, and then we end up having again description column, which will be describing the work to be undertaken or carried out or even executed. And here we'll be having the total, I don't know if I may call it total. Let me start by here. For example, you have two footings. Then here we'll be having number 2 regarding of the item we're working on. Here we'll be having the length maybe and the width, so that we may end up covering the square meters of this item called a site clearance. Here then we will be having a multiplication of these. If we are having example 2 similar sites, here we'll be putting 2, and then here we put the length of one site, and here we have to put another a width, and then we will end up having the square meters, of course, of site clearance to be carried out. So let's get started today with the course of today. Okay. I'd like to use a simple example to be learning about this. Okay. First of all, I need to fix this taskbar this taskbar thing so that it won't keep disturbing us. Okay. So I was saying about I've chosen to use this footing as an example where we're gonna be learning about taking off dimensions from a drawing to insert them in the takeoff list, and then we take the quantities we calculated in the takeoff list and we transfer them under the bills of quantity. So what the works do we actually need to carry out this footing and this sub-column to be constructed either by the contractor or anyone else? So the first and the very first thing to do is to clear the site where we're going to be constructing our sub-column and footing. After clearing the site, we'll need to excavate, of course. We may have oversight excavation, we may have bulk excavation, which is not included here. We may even have the pits excavation. And we may have, again, the trenches excavation, but here we're looking up about the footing only, so we will be having these two excavations only. We normally have two other items which I don't like to use oftenly. This planking and strutting and this item called disposal of water. This, first of all, planking and strutting is an item carried out where we seem to have a subsoil which is not strong enough to uphold itself, so we uphold it with the access or with the help of timbering process. The disposal of water is another item carried out under the circumstance which indicates that we have a subsoil containing a lot of water. You may be constructing in the valleys, in the swamps, so you need to dispose of the amount of water that may be underseen below. And then we'll be having again this anti-termite treatment where we'll be having to treat the subsoil with chemical products. We may be then having the formworks as it is a concrete structure. Of course, we'll need to formwork. We'll be having these formworks on the sides of the footings or column base. We may be having these formworks on the sides of subcolumns. Here we have another item named reinforcements, which I've chosen to highlight like this because we'll be calculating the reinforcements under this other sub-document, maybe if I can call it. So here in this reinforcement bar bending schedule, we normally have the member that we are working on. It may be a footing, a sub-column, a ground beam, or even a beam, a stair, and so on. Here we indicate the size of the steel bars being used. Here we indicate the number of members. If we have one footing, of course it's 1. If we have 4 footings, it's 4. Here we then have another column which is number of bars in each member. So in each footing, what number do we have of pieces within that footing? Here we have the total number of bars, which will be the multiplication of these two columns. Here we have the length of one bar, which we'll be calculating using the given drawings. Here we end up having the total length of all steel bars, which will be the multiplication of these two. And then we end up having weight as the general standard bits of quantity format indicates that we calculate the reinforcements under weight, so we'll be looking at it. Then after reinforcing, we'll be pouring the concrete, of course, under footing and the sub-columns. We won't be needing this item as it is walling, stones masonry, which is actually the foundation, which we won't need. We are normally looking about just the footing. So we will need to backfill as we've already excavated a pit, and then after constructing, after pouring our concrete and after it is hardened, we will need to come back and backfill this hole under which we've already excavated. We will need to compact, of course, and then finally we need to cut away the remaining soil. As far as I can tell, these are the mainly works we'll be having to see that footing being constructed. We'll be needing this, and these we'll be introducing them on our next course. So let's get finally started, and we'll do this pretty quick. We are having a footing of 2000 millimeter by 2000 millimeter, which indicates that it's 2 meter by 2. Another take-home note is that all estimation documents will be produced by using standard measurements format, which is metric system. We won't be using centimeters or millimeters. We'll actually put in meter. So we're having 2 meter by 2. So we're gonna be clearing this amount of area, which is here we have 1 footing, and here we have 2 meter by 2. Which gives us 4 square meters to be cleared. Again, you should be considering this description. You need to understand it, of course, and edit it when it's necessary. Then we come to the excavations. We'll be having oversight excavation, which is excavating a certain amount of depth, which is normally not more than 300 millimeter thick. So this is oversight excavating or removing the topsoil which may be containing, which is not strong enough, or even which contains vegetable soil. So it normally equal to the cleared site. Hence, we'll be doing excavation of pit. As we have 1 footing, we will have to put here 1, of course. We have a footing of 2 meter length by 2 meter wide. And then here we should be having the depth, and which will be looking here. So as you can see, we are having, they didn't indicate the depth or height of this total footing. So I'll assume if we have here a footing of 500 millimeter, which is 0.5 meter, let's just assume that from here up to the top or to the ground level, we are having another 2 meter, which is 2.5 meter. So here I will be putting 2.5 meter. We come up to the planking and strutting, which I measured, and item means that we don't have a standard measurement format to be measuring this, and same as the disposal of water. So we come to the anti-termite treatment. We'll be pouring this termite treatment to the cleared site, or where the building or our structure should be fixed. And we've already seen that we're having a column of 2 meter long by 2 meter wide. And again, we'll be needing to pour this anti-termite to the sides of footing. So we are having a 2 meter wide, and again we are having a 2.5 meter high. This is just one side of the footing, and yet we know that the footing has 4 equal sides, and you see that we'll end up having 20 square meters of the sides of footing. We move on to the formworks, which is measured under square meters. The formwork on the sides of the footing, as you can see, we are having a footing of 5 millimeter high concrete, and here we are having one side which is equal to 2 meter. So we have to calculate the formwork on this side, on this side, on this side, and this means that it's 4 sides, 4 equal sides, and yet we'll have to calculate the formwork of this subcolumn and on 4 sides, which are these. Okay, so we are having a 2 meter long footing, and yet we are having 0.5 meter high footing, and we are having 4 sides of footing, which should be giving us 4 square meters on the sides of the footing to be formworked. So as an example, of course, let's just have a look at this. If we are talking about the formwork at these sides, this and this is the footing, and these steel bars are for subcolumn. As you can see here, we're having a formwork on every side on the concrete footing, and we are having steel bars which should be holding up the subcolumn. Okay, as it seems to be here, we are having the formworks, the reinforcements, and the subcolumn steels. Okay, it actually looks like this. So we are having this side, this and this, which are 4 sides. That's what I've been working on. Okay, so here we are having a subcolumn, of course. We've already seen that our subcolumn is having 400 meter by 400 meter, which is this. So it means that we are having one side which is 0.4 meter wide or meter long, and then we end up having, as we've already said, that we assume that we excavated a pit of 2.5 meter, and yet this is 0.5 meter on the footing, so we are remaining with 2 meter of the subcolumn. So here we put 2 meters, and here remember that we are having 4 sides of subcolumn, and I put here 4, and we end up having 3.2 square meters, and this should be the product of all of these measurements. So we move on to the reinforcements. So let's get to this. As I was saying, we are having a member which is footing. We are having the size of steel bars which we're going to be calculating. They've already given us every detail about the reinforcements, okay? So we are having the lower reinforcements and the upper reinforcements. As you can see, the lower reinforcements is having less spacing than the upper reinforcements, which is obvious because the lower part will be the one carrying out the tension forces than the upper reinforcement layer. So let's start with the lower reinforcement layers. Here we are having number 3, which is this. We are having number 2, which is this, and I may call it these 2 intermediates, and we are having one upper layer. Of course, we are working on the footing. So, as you can see, on the number 3, they are telling us that this mesh or this layer is reinforced with 18 pieces of 12 millimeter diameter at a spacing of 100 millimeter wide, or spacing, of course. And as you can see, this flash is pointing on the steel bars going in horizontal directions. And yet here we have other 18 pieces of 12 millimeter diameter at the same spacing of 100 millimeter. And as you can see, it is the steel bars going under the vertical directions. So if you look closely, they are 12 millimeter diameter, which makes me put 12 undersize. The number of members, we are having one footing. The number of bars in each, as we've already seen it, we are having 18 under the horizontal layers, and we are having another 18 under the vertical layers, which makes me think that we are having 18 plus another 18, which is 36 pieces. The total number of bars will be equal to the product, of course, of these two. Okay. So the length of one bar, we're going to be calculating it. We've already been given it. As you can see, we are having 1,890 millimeter. We won't be having a reinforcement of 2 meters because otherwise it may be touching the reinforcement. So we are having this, and there's 2 bends of 240. So we will have to take this plus this plus this, which is equal to 1.89 meter, 89 plus 0.24. This is 1 bend times 2 bends, and Oh, sorry, I didn't indicate the equal sign. Okay, and we end up having 2.37 meters. The total length will be equal to the product, of course, as I said. The product of these, okay, means that we are having 36 pieces of 2.37 each piece. And what total length do we have? This is it. The weight I'll be talking about later. So we are having again the second row, which is these two intermediates. They are the same. If you look closely, they are telling us again 2 pieces of 12 millimeter diameter on this side, 2 pieces of 12 millimeter diameter on this side, and here on this side they are indicating the same. Means that on here we are having the same, even though they haven't indicated it due to that this side they've indicated the upper reinforcement. So means that on every side we are having 2 pieces of 12 millimeter diameter, and the reason why they are not the same with these 3 is because the second row doesn't have these bends. Purposely on my imagination, these are just to hold these bends, as you can see. So we are having 12 millimeter diameter on the same one footing, and we're having number of bars in each. We've already seen that we're having 2 on one side and we have 4 sides, which makes it 8. Okay, as I was saying, we are having, of course, 2 pieces on every side, and yet we know that we have 4 sides, which is equal to 2 times 4, which makes it 8. And here I just copy paste this formula, okay, the multiplication of these 2 columns. So the length of one bar, we've already been given it. It's 1.83 meter, and here I put 1.83. okay, here I apply the same formula. So I come up with this other, the final layer. Again, the reason why it's different from this, it's just the spacing. As you can see, the power reinforcement, they are telling us that we're having 13 pieces which are 12 millimeter diameter at a spacing of 150, means that on the upper layer we are having a less number of pieces than the lower ones, as I said before. You may even count. Here we have 1 piece, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Of course, they have to be 13. We are having 13 under the horizontal directions, and we are having 13 under the vertical direction. So it's the same. We just have one footing. We're having the number of bars. We're having 13 plus other 13. And we have 26 pieces. Here I apply the same formula. If you look, then we're having the same length, 1.83. Sorry. Okay, 1.83. Here I apply the same formula. So the multiplication of these 2. Okay, and here it's 12 millimeter diameter. Sorry. So we are done with the footing as far as we can tell. So we are about to be working on the subcolumn. They didn't give us a lot of specifications about the subcolumn, but we won't leave it undone. So I'll have to assume most of the reinforcements. Let's have this example. Okay. As you can see here, this is a random subcolumn or column details, but we're having 300 millimeter over 300 millimeter. But here on our footing, we're having 400 by 400. So let's use this, but we keep in mind that here we have 400, here we have 400. So I'd like to assume that we are having one steel bar here in every corner, and yet another one steel bar in every middle, so that we may have a clear reinforcement. Of course, we'll be having 1, 2, 3, 4, 5, 6, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 steel bars, of course, and let's make it 12 millimeter diameter too. So if you look closely on these given examples, we are having the same. Okay, this is the stirrup. So okay, let's look about this. So we are having this sub-column steel bar, and yet we are having something to be bent on the lower reinforcement mesh or layer of the footing. So let's assume that, assuming that there's a 12 millimeter diameter too, we're already having it in the sub-column. So we're having 12 millimeter. The number of members we are having, one sub-column. The number of bars, we've already seen that we assume that we assume that we are having four corner steel bars and 4 middle steel bars, which makes it 8. Okay, so on the total number of the steel bars, I apply the same formula. Okay, so on the length of one bar, we've excavated a footing of 2.5 millimeter. 2.5 meter deep. So whatever we do, we normally have to put 2.5 meter, and then we have to add the bend, which should be tied on the footing, as I was showing you. As you can see here, we're having this steel bar which is tied on the footing reinforcements, same as here we're having this and this. Okay, something like that. So we add this bend. If you are having a 2 meter long and wide footing, let's assume that the bend is 0.5. okay, and yet we'll have to add something again. So okay, let's say that this is the footing and the sub-column is, for example, nearby here, the sub-column level. So we need to add this tenting bars, or I may call it the overlapping bars, which they will be using if they want to add on the sub-column, the column reinforcements. So we may have 0.8 of overlapping steels, and yet we end up having 3.8 meter long. I apply the same formula here, and we get 30.4 linear meters. And we have what we call stirrups. Of course, as you can see, we won't just have these steel bars. We have to put in these stirrups, and they're telling us that the stirrups are at a spacing of 150 between each other. So if I have for example 8 millimeter diameter stirrup in one sub-column, the number of bars will be equal to 2.5 divided by the spacing, which is 0.15, and yet we'll be ending up with 16 stirrups. But here we shall be doing something like this. Okay, so I apply the same formula here, and here, of course. Okay, So the length of one stirrup, let's again have a reference here. This is the general stirrup form you may be using, or stirrup structure may be using. So as you can see here, we are having a 2.25 millimeter spacing, which is 0.025 meter. So we may even have a small draft. For example, here, if we're having a subcolumn which is having 400 millimeter wide, we deduct these two spacings. As you can see, it's on every side, and every side. So if we want this a single length of one side, we normally have to take this 300 and we deduct this 25 and this 25. As you can see, they've already done it here. We were having 300 millimeter wide subcolumn and they ended up having 250. That's what we're about to do. So if we're having 400, we deduct this 25 and this 25, which is 50, and we end up having one side which is equal to 350. And yet we know that we have, of course, four sides, so we're having 0.35 times four sides, and I'll be having to add something else, which is this bend. Of course, this and this, but here this bend is actually too much. So okay, let me use 0.05. As you can see, this was 0.1 meter, so let me use 0.05 because this is actually too much, except if we have a steel bar which is having a greater diameter, but on a 12 millimeter diameter it's actually huge. So let me have to take 0.05, which is 15 millimeter. Then I multiply it with 2 because we are having two bends. Okay, and then we end up having this length of one stirrup. So here I apply the same formula. Okay, so we are done with the reinforcements, every reinforcements. Okay, and let's see how do we calculate the weight. Of course, by calculating the weight, it's a simple formula. So we actually take this length, we multiply it by the size, but this diameter, we normally square it. So if you want to square it under Excel, so you have to put it like this. And after this, we multiply again. We multiply again with the 0.222. This is just a formula, or let me put it here. Okay, 0.222 times this length, and then we multiply it with this size squared, and everything here. Okay, then we divide it by 36. This is the formula should be known as an estimator. To see or to get the weight in kilograms, you have to take 0.342 or 0.222. Then you multiply it with the total length you are having. You multiply it with the size you are working on, which is 12, but the size should be squared, and then you divide everything by 36, and you end up having this in kilogram. I do the same on everything except here. Okay, you may even add up the reinforcements in the same member having the same size. Okay, so this is it. of course. So as you can see, we are done with the reinforcements, and what you will have to do in here, we'll have to specify, for example, let me correct this. Okay, you may say here under the footing, 12 millimeter diameter under the footing. Okay, we are having it in kilograms. Okay, here we'll be putting this amount. Okay, we are having again the same 12 millimeter under the subcolumn. Okay, we are having this amount. We then have 8 millimeter diameter under the subcolumns. Of course, we are having these kilograms. Okay, and you're done with the reinforcements, of course. So we go to the concrete. The concrete, we are having a footing of 2 meter. First of all, this will equal to this. Okay, and this, and it will have to double underline it, and here we'll have to single underline it. Okay, and we do it like this. So on the footing concrete, we are having one footing. We are having 2 meter wide by, if you remember clearly, we are having 0.5 meter high, 0.5, and we are having we are having 2 meter length by 2 meter wide by 0.5 meter high. We are having again one subcolumn. We are having 0.4 by 0.4 subcolumn over a 2 meter subcolumn, and yet we'll have to do the backfilling. As I said, this whole masonry stoning, these walling stones masonry won't be needed. The backfilling, of course, if you remember clearly, we've already excavated. Let's take it like this. We take the pit excavation, then we deduct, as it's a concrete structure, we deduct this concrete of the footing, and we again deduct this concrete of subcolumn, and we end up having this backfilling. Means that we should be returning this amount of soil within there, and then we compact. We normally compact, of course, the everywhere we are working, or the total site, or the total site under which the structure will be covering. Okay, that's why it's equal to the clearly side. And then we'll be having to cut away, and to cut away we'll be having this excavated soil. We don't cut away this over excavated. It's actually not a huge, and as it is stated in the square meters, we cut something which is majorly under volume. So we take this excavated soil, we deduct this, we use to backfill, and we end up having 2.33 cubic meters to cut away. So as far as I can tell, these are the works we'll be needing to carry out during this construction of the subcolumn. And then after having your quantities under the takeoff list, you will coming back under the bills of quantity. Okay, and then you start filling the quantities you've already gotten. So I'd like to do it like this. I do this and I go in the takeoff list. I simply put this. And to the oversight excavation, I do the same. Okay, oversight excavation. On the pit excavation, I do the same. Okay, the pit excavation. And keep going. The trenches, I don't have trenches. This was former bills of quantity containing everything. The planking and the strutting, we're having item, we may put here one and here one. The difference will be made by the unity rate. The anti-termite treatment, I can easily sum up this. On the anti-termite treatment, this and this, okay, and I end up having the total what. So on the stones, I don't have it. On the reinforcements, I have the 12 millimeter under subcolumns. I have 80 millimeter, column base and subcolumns, 80 millimeter of stirrups. I don't have ground beams. Have to exempt this. The formworks, I got the same. The sides of footing, I don't have the ground beams. Here I have the sides of footings and subcolumns. The reinforced concrete, I do the same. Okay, so after getting this, and you need to start working on the rate. For example, if I say here we are having a unit rate of 1,500 Rwandan francs, you need to state the currency you're working on. I'm using Rwandan francs. Okay, so then I get the multiplication of this. For example, if I say let's be the same or 1,000, and here I say the excavation, for example, 1 cubic meter, if we put 4,000 Rwandan francs, which is approximately 4 USD or 4 US dollars. I don't have the trench excavation. So the format should be indicated that here we have a subtotal of every page, as you can see. And at every subtotal, of course, you will have to indicate this. The total to collection of substructure means that we are working on an element of substructure, and we are having the subtotal one on the first page. Under every page should be this. And here we're having total to collection of substructure. We are having 2. The above one was 1. Here we're having the same, but it's number 3. On the above it was number 2. And then you will be having, after doing all works needed under the substructure, then you will have to work on the collection of every page. So this is page 1, page 2, page 3, and then you will have what is called the total to summary of substructure. Means that it is the total amount to be paid under the substructure element. And I like to use, as you've been seeing it, I like to insert this from the takeoff list, so that if, for example, I change something here, maybe I may have made a mistake, and here I'm having 2.5 over, for example, 3.5 meter. So as you can see, we are having 8.75, and it automatically changes in here, which is 8.75. So it's better if you hit equal, and then you go in your takeoff list, you actually type this, and then you hit enter, so that if you change anything under the takeoff list, it will automatically be changed wherever you use that figure within here. So guys, today was about the introduction on the estimation documents, which is the bills of quantity and takeoff list. We are still having more to learn about, to talk about, to share with you guys. And of course, it's not mandatory that things should be done my ways. So if you're having any other suggestions on how things should be actually done, don't hesitate to share it with us. It's not a must that things should be done my way, so please feel free to share with us. And if you haven't yet subscribed to the QS platform, this might be the best time, of course, as you'll be notified on every single video I upload here. So feel free to subscribe, feel free to comment, to share, and ask any question where you haven't understood clearly. I'm open to suggestions anytime. So I love you guys. Thank you.